you will bring. Welcome to Xion Little Champs 24, where innovation knows no limits.
Kamalthai Vartha. Kamalthai Vartha not only symbolizes our deep-rooted pride in our heritage, but also serves as a reminder of unity and strength that brings us together as a people. In this spirit, I kindly request everyone to rise for the Kamalthai Vartha.
சீராரும் வதனமென திகழ்வரத கண்டவிதில் தெக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீர் இளமை திறம் வியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Thank you, everyone. Before delving into the intricacies of technological wonders and the limitless creativity that lies ahead, let us continue to honor our traditions by lighting the Kuttuvalakku, symbolizing the dispelling of darkness and the illumination of knowledge. The lighting of the Kuttuvalakku is a symbol of the enlightenment that comes with the pursuit of wisdom and understanding. I now invite our esteemed dignitaries to join us in lighting the Kuttuvalakku. Thank you, dignitaries, for illuminating our event with your presence and for guiding us on this journey of knowledge and discovery. Dr. Shirley Edward Ma'am embodies brilliance, dedication, and leadership in academia. Her commitment to excellence has shaped our department and inspired many. With visionary leadership, she's led us to remarkable achievements, making our department a beacon of innovation. Beyond academia, she shows compassion and empathy, always ready to support others. With great honor and anticipation, I now invite Dr. A. Shirley Edward Ma'am to deliver the welcome address and inaugurate the momentous occasion.
Thank you, Smita. Good morning, one and all present here. The respected dignitaries on the dais, students, dear students, faculty members. So today we have gathered here to inaugurate the 13th edition of our national level Robotech Fest, Xion. Normally, every year, since its inception of this robotics club, every year we used to organize workshops, and as an annual event, we organize the Tech Fest with technical events and non-technical events. This time, there is a slight change in this robotics Tech Fest. So, normally the workshops will be also organized for school children. But we found that the school children are very enthusiastic in doing projects, and from the school, maybe from 6th standard onwards, students are doing many projects and they are participating in many competitions. So we thought we'll give a slight twist, slightly differently we organize this time. So we plan to organize the first day of the event as Xion Little Champs. It is mainly meant for the school children. So for them, we had planned to organize two competitions. One is Arduino Challenge and another one is Robotics Project-based competition. And initially we had very good registrations for the school, from the school. But due to the elections, all the exams are preponed, so we could not get many students on board today. But still, I appreciate the school students who had come here, although you have exams. They come here to participate in this competition. I really appreciate and so to you students who are present here. I warmly welcome all the school students and the teachers who had accompanied them. A warm welcome to you all. First of all, I would also like to thank our management for permitting us to organize such kind of event in our department. And I would also like to thank our chairman sir, the director institutional development, Ms. Harani ma'am, and also our director academics, Dr. Ramachandran sir, for supporting to organize this event. And also they could not come here due to their official engagements, but they had sent their greetings to us to organize this event. So in absentia, I warmly welcome them. And now I would like to welcome our chief guest for the day, Mr. Keshav Kumar sir, who is a scientist in National Institute of Ocean Technology in Chennai. I thank you very much, sir, for accepting our invitation and being present here. On behalf of our management and on behalf of our department, I warmly welcome you to this Xion Little Champs event. And sir is going to excite all the students, school students as well as college students with his speech on marine robotics. It will be different of its kind, whatever you have heard till now. So we warmly welcome you, sir. And now I would like to welcome our Dean sir, Dr. C.V. Jayakumar, who is always a strong pillar of support and encouragement for all the activities in our department. We welcome, sir. I would also like to warmly welcome our VP Academics Madam, who is also a senior professor in our department, for her constant guidance in all our department activities. Welcome, ma'am. And I would also like to congratulate the event coordinator, Mrs. Akila ma'am, who has been working for more than a month to organize such an event. So, welcome, ma'am. I would like to welcome all the HODs, vice principals, research coordinator, and the other faculty members who are present here. And I would like to extend my special thanks to the HODs of other departments and also our maintenance team for supporting us in various aspects to organize this event. Thank you very much. And last but not least, I welcome all our students for this Xion Little Champs 2024. I hope this event will be very useful for you. You will get lot of technical points from the chief guest so that you can do some research work on the topics what he is going to talk on. And I wish all the participants all the very best. Thank you.
Thank you, ma'am, for your warm and cheerful welcome. Her relentless pursuit of academic excellence has not only elevated our institution, but has also empowered countless individuals to reach their full potential. As a beacon of inspiration and guidance, her profound insights and unwavering commitment to student success have transformed our academic landscape. Her strategic initiatives and unwavering dedication have empowered countless individuals to achieve their aspirations and excel in their chosen fields. Yes, we speak of our revered Vice Principal, Dr. C. Gomati ma'am. With utmost delight, we extend our invitation to her to share her profound insights and wisdom in the special address.
So, welcoming once again to this Saravanahalli campus. Mainly the school students who come from various schools to participate in the competitions, as well as the expert speech which will be offered by the scientists from the National Institute of Science and Ocean Technology. So on behalf of the campus, once again, let me welcome sir to this robotics fest. So this time, as Madam said, usually it will be conducted as a single symposium as far as robotics is concerned, only as a Xion. And with an idea that we'll be having a separate kind of events for the schools as well as colleges. We thought that we'll do it as Xion Little Chance on the first day, continued with Xion on the next day for the college students. But anyway, as due to the other unavoidable reasons, we could not have many of the schools participating, but still, I just offer a warm welcome to all the participants who come from various schools for this event. And as such, as far as this robotics and other things are concerned, as Madam rightly said, in schools nowadays they are incorporating more of a, kind of input as far as robotics is concerned. And you also would have seen onto this stage a display of various robots which have been done in the various workshops, and that actually marks the decoration of this particular robotics theme. And really I appreciate this kind of a gesture on a robotics symposium. And I thought that let me introduce to you few developments which are actually happening in robotics. So first of all, earlier, maybe before 20 years or 30 years and all, everything was only hardware oriented. When we think of robotics, it is all like some hardware which can automatically it can run or do some job and all that. So it is all hardware oriented. Now that any particular field for that matter, we can't just discriminate hardware and a software. You have to have a proper mix of both hardware and software that we could have the full benefits of such an advancement. So with that idea, now that an important software is connected with the robotics field. Can anyone name that what it is? An important software. AI, right? Artificial intelligence that is connected with robotics. And for that, there is one AI connected tool. Can you name that? Many of you might be using it for your projects and all that. AI connected tool. What is it? ChatGPT, right? So with the ChatGPT and other advancements which are happening, AI is actually becoming one of the important tools in order to design your robotics, and that actually makes the functioning of a robot in an industry much easier. With the commands which have been given, with the artificial intelligence which is incorporated to the robot, they are able to do, Herculean tasks with ease. That is one of the advancements which has happened. And secondly, I want to introduce to you this particular term called cobots. So far we know only about robots. There is also yet another term called cobots. We are actually mixing up two different terms, and this particular word is being coined called cobot, which is none other than collaborative robot. Right? So it is only a robot, but again, this is actually for doing some kind of a task. Maybe it might be some kind of a dangerous environment where the robot may have to go and do some work and all that, where you make this particular technology called cobots. And thirdly, the third advancement which is actually happening in the today's world is called, you all would have eaten this particular famous dish called momo, is it not? Likewise, in Robo, you got a famous term called MOMAS, mobile manipulators. Mobile, MO is taken from the first word mobile, manipulators, MA, and you are actually coining that particular term called MOMAS, mobile manipulators. What is it actually meant for? Is that for the automobile, aerospace industries and all, now we are actually going with a simulation kind of a thing. Those kind of robots are actually called as manipulators, and which will also be mobile. They can move around and they can help you with a simulated environment. So they are actually called as MOMAs. That is your third advancement which is happening. And the fourth one, which I want to point out here, is digital twin technology. You already have got a human who is actually working. You can create a replica of the human who will be twinning, right? And those things will be made with the help of some digital technology. So that we call it as a digital twin technology. So that is the fourth advancement. And finally, we all know that in Japan and Korea and all, nowadays one particular robot is very, very famous. Can you name that? Which will be almost looking like human, which will be doing a kind of interview, or it will help you with the daily domestic tasks and all that. It is called as a humanoid robot. And there are many names given in various countries and all that. So that is the fifth advancement which is happening in the robotics field. So I thought that I'll use this podium to just introduce to you these advancements which are happening in this field. So once again, on behalf of the department as well as on behalf of the SRMIST Vadapalani campus, let me welcome you once again to this robotics Xion Little Champ competition and symposium. Thank you so much.
Thank you, ma'am, for your enriching words. We are thrilled and honored to extend our most heartfelt welcome to our Dean, Dr. C.V. Jayakumar sir, an eminent leader and visionary in the realm of engineering and technology. With an abundance of experience and profound expertise, our Dean has played a pivotal role in sculpting the academic terrain and nurturing innovation at SRMIST Vadapalani campus. His unwavering dedication to excellence, strategic foresight, and unwavering commitment to student success are nothing short of awe-inspiring. We are privileged to have our Dean grace us with his presence and deliver this special address. With immense pride, we now extend our heartfelt invitation to him to grace us with his presence and deliver this special address.
Good morning. Good morning. Hello, yeah. Let's stay with. Okay. Good morning. Dignitaries on and off stage, dear students, dear most visitors and students from various schools. At the outset, I would like to congratulate the school students and the teachers and the management for having permitted the students to come over here and then participate in this competition, in spite of their the exams being postponed due to so many reasons. So, welcome to you all. And what we have observed is the creativity of the school students is far better than the senior students, which we have seen in the previous years. The way in which they make the robot and the purpose for which it is made, irrespective of the size, it's all appreciated. And I'm sure that this year also the display or the products would be wonderful. And I don't want to take much of time because our Vice Principal Madam has given a small sort of workshop about what robotics and robots all about. And I'm also really awaiting to listen to the speaker, the guest, who is going to touch upon the marine or underwater robotics. I mean, it's totally a learning process for me as well, meaning. So, welcome you once again and wish you all a wonderful day. Let us not be bothered about whether I get a prize or not, but participation itself is one step ahead compared to the other students who could not make it to this. So, wish each and every one of you a great success and have a wonderful and pleasant day. Thank you.
Thank you for your inspiring words, sir. I now request our Dean, Dr. C.V. Jayakumar sir, to felicitate our chief guest with a nut bouquet and memento.
Thank you, sir. Mr. B. Keshwakumar is working as Scientist E in Electronics Division of Ocean Observation Systems, Group of National Institute of Ocean Technology, Ministry of Earth Sciences, Government of India. He has over 12 years of experience in design, development, installation, and maintenance of offshore platforms such as deep ocean tsunami buoy systems and moored data buoy systems. He has sailed on board Indian and international research vessels as chief scientist in coastal, deep ocean, and polar region of installation for buoy systems. As a project leader, involved in design and installation of India's first mooring in Arctic region, close to North Pole of the Earth. He is involved in optimization of power requirements of autonomous ocean observation systems, satellite telemetry system, autonomous marine vehicles, renewable energy system, satellite remote sensing of oceanographic parameters. He has published 8 research articles in peer-reviewed international journals and 14 papers in international conferences and filed 4 patents. He is also actively involved in transfer of innovative technologies to private industries. As a part of capacity building exercise between Indo-USA collaboration, he was deputed to National Data Buoy Center at Stennis Space Center, NASA, USA for training. He has received the prestigious National Geoscience Award from Honorable President of India for the development and establishment of Indian Arctic Multi-Sensory Underwater Observatory at Arctic region. He is the recipient of Outstanding Young Engineer Award from the Institution of Engineers, IEI India, in the field of marine engineering during the year 2023. I take an immense pleasure in inviting our Honorable Chief Guest, Mr. B. Keshwakumar, to deliver the inaugural address.
Good morning to all the students and respected dignitaries of SRM. And the slides are visible at the last show. Friends, is it visible? Okay. So I'm Keshav Kumar, and thanks for the introduction given by our friend about me. And I'm really happy to note SRM is going to the grassroots level, like as Dean sir, Dr. Jaikumar sir, and Gomati ma'am, and Dr. Shalima rightly pointed out, the young minds gives more ideas. Like the creativity is uncomparable with the, when they grow up. Like in school, they have more of creativity and other stuff. So I really thank the management of SRM for getting into the grassroots level opportunities from the young students. So my talk today will be touching upon autonomous ocean observation systems, and I will touch upon underwater vehicles. How much time? 20 minutes. Okay. My presentation will be approximately for 20 minutes, and at the end of the session, please raise for questions, queries, or anything may come up for. Next slide, please. So I'm from National Institute of Ocean Technology, which is having the main campus at Pallikaranai, and also we have offices at Andaman and Nicobar Islands. I mean, could it be interactive? Yes, sir. Okay. So, how many of you have gone to Andaman? Andaman Islands? Anybody? Namas, right? Okay. Please do visit and try to see what is the differences like we are in Chennai and other places. So try to visit more places like that. And also we have a campus in Nellore. So let's get into the presentation. Next slide, please. So the Ministry of Earth Sciences and the Government of India, previously it was named as Department of Ocean Development. So the head office is at Delhi, at Prithvi Vigyan Bhavan. So under Ministry of Earth Sciences, there are 10 offices working on various portfolios. Like the National Institute of Ocean Technology, NIOT, where I come from, is basically an engineering institute, which is involved in development of projects related to ocean non-living marine resources. There are institutes working on living marine resources, and there are centers like Indian Meteorological Department. You might be knowing, you are getting the weather reports from them, and cyclone warning and other reports from them. And interestingly, the weather reports like the cyclone rain information is provided by IMD as well as the private weather forecasters are like having more than 98% of confidence levels now. There is a reason behind that, and I will explain that in the slides upcoming. And we have a National Center for Seismology working on the seismic, like they say Richter scale, right? The earthquakes are measured in Richter scale. So there is a separate office working on that domain. And there is a National Center for Earth Science Studies. It is Nexus, it is at Trivandrum. They work on geological aspects of Earth mainly. And also they touch upon chemical stuffs and the plate tectonics and other activities. And there is an Indian National Center for Ocean Information Services at Hyderabad. So they work on providing the ocean state forecast, the potential fishing zone. Say for example, if a fisherman is going for fishing, there will be information. You can go to this location. There are probabilities of getting more fish catch here. So, and also the tsunami warning information is designated by this office from Hyderabad. And we have a Polar Ocean Research Institute at Goa. So, or in that, there is Arctic mooring work is jointly with NCPOR Goa. And also we have a National Center for Coastal Research working on coastal ocean research, and CMLRE working on the living marine resources, and IITM, that is Tropical Meteorology at Pune, working on the meteorological aspects. And also we have a National Center for Medium Range Weather Forecasting, basically working along with IMD for forecasting the weather. So this is the gamut of NIOT activities. Like we have different departments in NIOT, energy and fresh water. So unlike our normal reverse osmosis based desalination, this is very different. And happy to say that most of the islands in West Coast and also the East Coast, that is Andaman, also is being implemented with this technology. Even before 2 months, our Honorable PM has inaugurated one plant in the Lakshadweep Island. And there the technology is different. It is not reverse osmosis. It is LTTD, that is low temperature thermal desalination. They use the delta T. That is, anybody can tell me what will be the temperature of sea surface, like when you are going in boat. Okay, imagine you are in a boat and then you touch the water. What will be the temperature of water? Any idea? Any rough guess? school students, particularly. You can say me even wrong answer. Saying a wrong answer will fetch you a gift. Will it work? Degree Celsius, you can tell me. Celsius, 100 degrees. 100 degrees Celsius is what? Yes, 0.1. So, fishes will die now. You will have fish curry from the top of the oceans. Any guess? What is the temperature? Yeah, 30, 20 plus, all correct answers. Okay, so what will be the temperature at the depth of 1000 meters? The ocean has depth, right? Like a swimming pool, it has two regions. One is the surface and the other one is the bottom. Some people will be diving down and touching the floor and say, I have touched the bottom of the swimming pool, right? Like that ocean also has sea bed, and the place where you access from the boat is called as sea surface. Okay, so you have various depth up to like the deepest point is 11 kilometers. Average depth is 3.5 kilometers, 3,500 meters. So at 1000 meters, what will be the temperature? Any guess? Any rough idea? Yeah, somebody is telling the answer.
10.
Yeah, something like that, 10 degrees. Okay, so there is a reduction in temperature. So you have a delta T now. Top 30 and bottom 10. Okay, when you have something like this, when you have voltage difference, you can have a current flowing, right? Like this, you have a delta T. With this delta T, this plant works. Like basically, they take the water from the surface and then they vacuum it. And there is a relation between pressure and temperature. Anybody can tell me? This P is equal to RT, right? Directly proportional. So when you reduce the pressure, you can have the water boiled at room temperature. So they boil the water, and then for the water is boiled, the steam is up. So leaving away the salt particles, steam is settled on top. Now we need to condense it, right? So they use the cold water from the 1000 meter. You have fresh water, drinkable water. This is the technology. And we have offshore structures. Basically, to do this, you need to lay pipes and all for 1000 meters. So there is an offshore structures department. And ocean observation systems, where I come from, they maintain buoy systems, basically. Tsunami buoys and weather observation buoys. I will give you full details on that one. And there is a marine biotechnology group and ocean electronics, basically, for the sensors. And there is a gas hydrates and CO2 sequestration group. There is a coastal and environmental engineering and vessel management. We have a lot of vessels with us for going into deep sea and performing research. And this rightmost panel, can you see this? This vessel is Sagar Nidhi. This is India's pride. That is the first ice class vessel of India. It is a double hull and has gone many times to Antarctica. Antarctica, what organisms of what marine species you have? Any idea? Will you have polar bears? Polar bear and Antarctica? Polar bear or penguins? Penguins! Will polar bear be there? Any idea? See, the scientific name of polar bear is like Arcticus. It starts like that. So polar bears are the organisms of the north, not the south. You can't find, but many pictures depict polar bear and penguin together, but it is a myth and it cannot exist. Okay. So this vessel is like a floating laboratory. It has all the laboratory. Students will be doing some physics experiments and all. No? So there is a spectrophotometer, grading experiment, chemical lab, a biology lab. All sort of labs will be there in the ship itself. It's like a floating laboratory. You can perform all sort of experiments. This is the main portfolio of NIOT. We work on energy, water, food, natural hazards, industry, and naturally new talents like you people. And also we have students similar to this competition. We have a students autonomous underwater vehicle competition, wherein students will be given a task of designing underwater robots. It has to do the specified task, and then it has to listen to a biggest frequency. These students, once selected in this competition, will be funded by NIOT for attending the international AUVSA competition at USA. Many students have gone this. Interestingly, young students, you should listen this. So there was a team from IIT Madras long back. And that person was like second year or so when he started competing in this competition. Slowly, he got expertise in the image processing techniques for this underwater robots. And he after completing his degree at IIT Madras, he had offers for more than 60, 70 lakhs per annum. But he denied all that one, and then he started a company in Sele, like Tambaram. It's near Tambaram. Now he is having projects worth more than 2 crores from US companies. So, like people like you, when you focus your energy and then start working on your own skill set, it will be a game changer. So, like that, many industries have come up due to this competition. So, organizing competitions like this is really a good initiative. That's why I would again like to thank SRM also, because it is going to lead into this sort of spin-offs. These are all some of the facilities of NIoT. Like, say for example, NIoT work in deep oceans. Like the country is only one institution who handles instruments more than 1,000 meters of this NIoT. So most of our items, say for example, this mouse pointer is there. Okay, when you imagine not a mouse pointer, imagine a transformer, like which transforms voltage and current from one side to the primary to secondary. If this transformer needs to be made to sit on seabed, then what are all the modifications need to be done? That can be simulated in lab. That is the facility. We have a hyperbaric chamber where you can simulate 900 bars of pressure, which is equal to 9,000 meters. And these are the results. Yeah, interesting. Anybody want to go in ships? Nobody? Yeah, there will be some programs arranged. You can get in touch with us. Some open office will arrange with ship. Yeah, coming to the ocean observation. I have a few slides on ocean observations, and then we'll go to the more interesting topic, that is robotics related to manned missions. So, why we need to observe the Earth? Any students? Why we should observe the Earth? Give me some answers from that side. Why we should observe here? Why we should measure something from here? Yeah, be loud. Actually, giving wrong answers will definitely fetch you something interesting. Yeah. Yeah. That's the correct answer. To detect natural disaster. How do we do that? We need to, yeah, please clap. What's your name? What's your name? Vishnu, very good Vishnu. So to detect natural disaster, we should definitely detect some parameters. Like say for example, if you're not feeling well and if you're going to the doctor, you will have headache and body is temperature. What does the doctor do? He will measure your temperature, he will check the pressure, like that, right? Similarly, we also do the same thing in analogous to the doctor. Like we measure the ocean parameters, temperature, pressure, salinity and other stuff. How it is done, you can go and measure, right? You can go in a ship and then measure and come back. Or else you can have a platform stationary there doing that work for us. Or else you can use a satellite for measurement, right? Indirect measurement. So these are all the different ocean observation systems. First is tsunami buoy systems. You all know about tsunami, right? What is a tsunami? Tell me any answer. What does a tsunami does? To people coastal infrastructure. Is it good or bad? Good, very good. So tsunami waves are unique. In fact, I have some slides on that. We'll see in detail. So that system, and then we have automatic weather station on ships, the buoys, radar, and the bottom are the instruments. And interestingly, the rightmost, the last but one, Argo floats. It's a kind of semi-autonomous robots wherein anybody how a submarine sinks down and comes up. You know submarine, right? How a submarine sinks down and how a submarine comes up. How? Please, correct. Pressure. Oh, what do you do? Say, for example, you are inside a submarine. I want you to sink to submarine. What do you do? What all the answers you are discussing is correct. Say it louder. Kind of correct. Say you want to sink, you take more water inside. Okay, your weight will increase, right? Then you go down. Then you pump out the water to some non-return water. That is water should not enter. You will be light and then you will be floating, right? Similarly, this semi-autonomous robot will do the same thing to measure the ocean temperature, pressure, and salinity. This is the locations. So this location, when you go in ships, will not have any connectivity. Like your mobile signals won't work. You don't have any other mode of communication except satellite communication. So we use different types of satellite communications for this application. These are all the buoy systems. How it looks like in the ocean. The first one is a basic meteorological ocean buoy. Second one is Omni. Omni is ocean mode. You can imagine it is the location of this network is in northern Indian Ocean. Right? You have Indian Ocean. Northern part of Indian Ocean is also there. The rightmost one is a tsunami buoy system. These are all the mooring configurations. Right. This tsunami buoy system has a sensor at the seabed itself. That is at a depth of 3,500 meters. So, what is approximate pressure at that depth? Anybody? What is the formula for pressure? You're studying now. You have examinations coming up. Correct. Tell me. That's question. Correct. Coastal area. And if you have and again, you can have the head, hydrostatic head. When you have height and when you have density, how do you calculate the pressure? Yes, from the density times your acceleration with gravity and edge. So the pressure there is 350 bar. Okay. To give an analogy, what is the pressure in your car or bike's tire? Any idea? How much pressure? You feel pressure? Bike or car, right? What is the pressure? It's approximately 2 bar. Okay. 28 psi, something like that. Pounds per inch. Bar is 2 bars. So 350 bars. So something leaks there, will not leak. It is a water jet cutter at very high pressure. It can cut anything and damage instrument. So this instrument is kept at seabed for complete 2 years of operation. And after it will detect the water level variation. And if there is any tsunami signals coming up, it will give a signal to the floating surface power systems, and then from the satellite we receive the data. All these things happens within 5 minutes of detecting tsunami, and after 5 minutes, tsunami waves takes like approximately 1.5 hours to reach Chennai, for example. Immediately getting this signal, all the coastal population will be instructed about tsunami. They can be evacuated. Only the persons can be saved. The infrastructure or other things, if you ask me, there's no any presently way to protect those things. Because moving that within 1.5 hours is really tough. How like, what do you think? What causes tsunami? Yeah, exactly correct answer. Name. Raise your hand and say your name. Vishal. Very good, Vishal. Yes. Yeah. So tectonic plate movements causes this. When you get this not a full connected plate, right? It has some ridges and openings and switches kind of thing, like how our skulls are made of. So when you have a movement like this, all the water column above this will be tapped from the down, and it will be similar. You can compare it to an analogy of throwing a small stone in a bucket of water. From the top, if you drop, it will create some like the circular patterns, right? The same happens when you tap from the bottom also. So that will travel at a very high speed at higher depth, and then the speed, like it will be full of kinetic energy when it is generated and it is coming from the sea, in the deep ocean. Once it is reaching the coast, you are putting a brake basically, right? The depth reduces and you are breaking the water. So all your kinetic energy will be converted as potential energy. The wave height increases and it dumps everything inside. So this is one application of the mode buoy systems. Whenever cyclone forms, there are more possibilities for the cyclones to form off Andaman tending the channel, and then it comes this way. So we have a network of buoy systems, and it is tracked in this way. And these data sets are open to public. So with this data from 2010 onwards, all the buoys are live and functional 24x7. So the IMD and as well as all the forecasters like Facebook or other social media are able to give good prediction based on this data now. So we are almost close, like 98% confidence level we can say it's going to be a cyclone, and this is the path of the cyclone. This happens right now because apart from satellite measurement, now we have ground truth measurements. This shows how we deploy a video. Someone is sleeping, please pause the video, it will give you a boost. So this is how the buoy systems are made ready. This is on board a ship. So we connect and the buoys are deployed. And this is how the ropes are paid out. Imagine like you are having a balloon tied up with a rope, and then there is a this is the big sinker weight, metal weight of 2 tons. So it will be deployed so that your buoy is in a position where we have deployed it. And this is the radar, how it looks like to track the buoy systems. And after deployment, this is how the data is transmitted to the satellite and then to NIOT. This is the data schematics. And then this is how the system is retrieved. Like for retrieval, the ship will go close to the buoy systems, and then after actuating the acoustic release, so this will command this portion to break off. It will break off, and then it comes off. So underwater, all this RF-based communication fails. It cannot happen. So only possible mode of communication at long distance underwater is acoustics, like sound, like how dolphins used to communicate or blue whales used to communicate. No, they basically make sound waves. And then the mooring is retrieved, and the buoy will be taken on board using a boat. This is how. Okay, this buoy system will have all the sensors for measuring air pressure, temperature, humidity, radiation, solar radiation, short wave, long wave, and all sensors. And this is the tsunami buoy system. Yeah. Out of these many countries, we could proudly say 2 countries are only making their own tsunami buoy systems, including the seabed unit. That is, one is the United States of America, and second is India. So with this, we are now the authorized regional tsunami watch provider for Indian Ocean Rim countries, and the designated office is INCOIS, Hyderabad. So they are authorized to issue the bulletin and warnings to the coastal fraternity. So you can see the depth is 4 kilometers from the buoy systems to the seabed, and all the state-of-the-art technologies are up and live and running. So something like 2004, if some scenario happens now in future, the government is fully equipped to tackle that situation. And coming to the interesting topic, the submersibles, robotics, marine-related robotics. Yes. You see the consolidation of all the NIOT's activities in deep sea robots. These are basically deep sea robots. So apart from the controller board, what controller boards you are using for your robotics projects? Anybody? Arduino. Mostly Arduino, right? It's cheaper and it's versatile. Like that, I can tell details of these robots also. So the first one is a mining machine. It is a crawling machine basically. So it goes down to seabed like 5,200 meters, and it is like a brooming. Basically, it has a collector system, and they mine polymetallic nodules. These are like deep sea minerals like cobalt, nickel, and manganese. So India has been allocated a huge area in Central Indian Ocean Basin by International Seabed Authority. Okay, so why do we need to mine these minerals? Anybody? At that much depth, taking the ship, which is very expensive, and then going down there, complicated process. Of course, Earth has resources, but in future, if you think after 500 years or so, we will be depleted of minerals, right? So this technology is in place to mine the deep sea minerals. And then comes deep ROV, that is remotely operable vehicle. So this ROV has already gone to 5,289 meters and it has dived 44 times. And the year it was started is 2010. How it is done is from the ship they will have a tether going down. Tether is nothing but a wire, an umbilical wire they say. Umbilical is like the baby's umbilical. It has optical fiber cables for communication, and also the power cables will be there. So with that, this vehicle can be controlled. This vehicle has all the state-of-the-art equipments. Like will have a robotic arm with 7-degree freedom arm, and it will have water samplers. It will have some bottles for collecting water samples at deeper depths. Next comes the soil tester. When this instrument is landed in water, in seabed, it should not sink, right? So they have a soil tester. So what it will do, it will go sit down and it will check the shear strength of the soil. If it is more clay, then the vehicle may sink, right? So to test that, they have this. And then this is the pouring system. This is interesting. It will go down to the seabed, and from the seabed, it starts drilling down to take samples. Like what happens is, see, basically, you will be knowing sediments, right? The river flows down to sea. So the river carries all the minerals and sediments down to the seabed. So, say for example, before 100 years, there will be a sediment deposited, and yesterday there will be almost sediment deposited on top like this. So when you drill and then see, you can go to history. You can rewind the time scale and see what has happened. Like when you drill approximately to like 600, 700 meters, then you can actually see like millions of years before how what sediments has come in, what has deposited like that. That is this machine. And this ROV, the remotely operable robot, is for polar applications, where it does special gadgets for tackling the polar condition. Like, say, for example, when this vehicle is coming up, there will be ice formed on top of the sea. So that time it has got a special heating element to melt the ice and then take some samples. And this is also interesting. This is an autonomous underwater vehicle. This was in fact procured by NIOT for some strategic applications. This is interesting because anybody remember this AN-32 mission? A Coast Guard Dornier aircraft, which has started from Chennai on the way to Port Blair. In between, it was missed. 2016. Anybody had read in the news about this thing? Happened. Okay, and then the aircraft grounded, and they were not able to find the aircraft. And recently, before 2 months or so, using this vehicle, the traces of the aircraft was found at 3,000 plus meters of depth from the Chennai, and it was published in all the leading newspapers. So, what is specialty in this autonomous underwater vehicle is it can go very close to the source. It can go actually. It's like, say for example, you can take the picture from here, the last person, and going very close to him and taking the picture. Like that, it can go. And then this is country's pride. So 3 persons are going to be sat in this vehicle, and they are going to be taken down to the seabed. This will happen in 2024. Maybe we are months ahead from the deployment. More details on this. Yeah, this is Matsya 6000. So it is a small mobile undersea research vessel. It is like a submarine but not submarine, because submarine is mostly for defense application. This is for deep ocean research application. So it has the explorer views here. So this capsule is for the man, and this is a lot more complicated than taking a person to space, because space the differential pressure is very low, but here inside this chamber the pressure is 1 bar, and outside the chamber the pressure is 600 bar low. So the material has to sustain this difference in pressure. So it will be made with the titanium alloy, or the complete titanium with very high thickness, and it has got a lot of batteries and other robots, small robotic arms for operating. It has got a lot of emergency weights here. Say for example, they say it is jettisoning weights. If there is any problem, it can release the weight and then it can come up to the surface. And this is the technical specification. It is rated for 6,000 meters, and the personal speed is 2.1 meter. It can have 1 pilot and 2 crew members. Anybody is interested to go in this mission like this? One person has gone deep in Mariana Trench at 11,000 meters. recently in 2012, and there is a movie about that. Anybody, any idea about that movie? Yeah, some answers, please. Titanic? Yeah, something related to Titanic. He's connected with Titanic. Yeah. You said that. Please be louder, any answer? James Cameron. Anybody know who's James Cameron? Yes, Titanic director, Terminator director. So he has gone to the deep sea at Mariana Trench at 11,000 meters using his own vehicle, Deep Sea Challenger. Similarly, this vehicle is completely designed and made in India for our own applications. So the endurance is for 12 hours, and the emergency support system is ready for 96 hours. Recently, some accident also happened. Anybody idea about that? Some people went down near Titanic and there was a catastrophe. Any idea? Ocean Gate. Exactly. Clap for it. What's your name? Prabhanjan. Very good, Prabhanjan. You are remembering the news. So, where the root cause for failure of that vehicle is they were using the carbon fibers as a material for encapsulating the human sphere, where it is subject lot of technical analysis has been done. This particular vehicle is full of titanium sphere, so there will not be any problem with this one. And this is the batteries. Which battery you are using for your Arduino robot? 9-volt battery. Very good. That is also called as a LiPo battery, right? Recharging battery. We use the same batteries for this one, but it is designed for tolerating high pressure. This is some footage. This is the location where we walk in. Like you have the depth here is 3,000 plus meters. And the distance from shore, from Chennai, it is 600 kilometers. This is how the systems are deployed in deep sea. So you can see the footage showing a lot of fishes nearby. There's a lot of challenging, my friends. Like to have system in place like this, what happens is you'll have a lot of biological growth, like algae and barnacles and other stuff. So when you go after 1 year for retrieving the system, it will be completely covered with a lot of biological organisms. And to maintain this, it's a really tough task. So a lot of people is behind this pain. Like they are working untiringly, going on ships, leaving their families, and a lot of work is happening to give the data. With that data, people are able to predict the weather system, like will it rain or how the weather the cyclone will be forecasted like that. And yeah, it's done. Please get into the presentation. The last. Last slide. Last one. Yeah. This photograph's interesting. It's from Arctic region, shot by me. It shows the 3 crowns. It is very close to the North Pole, which I was mentioning. So I'm done with my presentation, and this is my email ID. If you have any doubt or any queries, please write to me. Send me an email. I'll try to respond within like few days or so. And now the last part. Any questions? Any observations? Unlike the land-based robots, the marine robotics is very complicated in the sense that, fine, like thinking, AI, all applications are there, but still the mechanical integrity of the system should be perfect. Like when you design an enclosure for encapsulating the batteries, because seawater is full conducting, right? If something gets exposed, it will be catastrophic. So that aspect needs to be considered, and a lot of experience is also required. So you can have dream of building your own biomimetic based fish kind of a robots, something there. Already some are there, some octopus kind of robots are there, some small snakes kind of robots are there. So you can have some vision of developing something in the future, particularly the young ones. Any questions, queries? was expecting a lot of questions from schools. How it works, will it work like this, will it not work, what do you do with that? And please don't feel shy to ask basically a foolish question because those questions have turned the world upside down. For sure. And batteries, you can ask me. We deploy the system in C and then we let it for 1 year of operation. So what kind of batteries do we use? We use a special kind of primary lithium batteries. Unlike your rechargeable batteries, it cannot be charged. It's a primary battery. The energy density of the batteries is so high. Say, for example, if you have a 1 kilogram of lead acid battery, okay, the energy density of lead acid batteries is 50 watt hour per kg. If you have 1 kg, then you can light a 50 watt bulb for 1 hour. It runs for 1 hour. That is 50 watt. The battery which we use for our application is having an energy density of close to 800 watt hours per kg. Same, if you have this battery, then you can light an 800 watts bulb for 1 hour, or you can light like 400 watts bulb for 2 hours like that. Okay. And really my best wishes and advanced wishes to all the young students. Really happy to see a lot of projects here. Yeah, please.
Sir, how many times takes for the signal to come from the robots? Sir, tsunami robot.
Fine. Basically, what you're asking is the telemetry time. So when the voice systems we have seen, it is already in the surface. So from surface, less than 5 minutes, the data can come in. We're using different satellite telemetries. We use Inmarsat satellite, that is International Maritime Satellite System. Okay, that is a geostationary satellite. And also we are using Iridium satellite now. With this satellite telemetries, it will definitely take less time, less than 5 minutes they say. But to me, practically, if you ask me, we have seen data even less than 2 minutes or so. This is for the floating system. But there are some devices like the autonomous underwater vehicles or the gliders and stuff like that. That will need to navigate down below and then come up. So to send the data, it has to come up to the surface. So that time plus your transmission time is added.
Thank you, sir.
And one more question, connected observation with this. In land, if you have a vehicle like this, a rover or something like that, like the Curiosity rover, you have GPS signal with you, and then you know where you are going, right? But when this underwater vehicles, when they are down below the water, how do they navigate? Say, for example, this blind, no? Sonars will be there, but I can ping if something is there. Sonar will go, if some reflection is there from there, but nothing will be there. It will be a full water only. So I need to go, I'm blind, I cannot see also. Visibility will be poor. I need to go from here to there. How it is done? Any ideas? No GPS. GPS will not give you are in this location, the waypoint will not be there. You will be given a waypoint, but GPS is cut. Any idea how it is done? Yeah, LIDAR is one thing, but LIDAR also needs reflection. It needs to get reflected from something. When reflection is there, you are exactly right, you can get it, but no reflection. It needs to navigate. How it is done? Yeah, just dead reckoning navigation. Dead reckoning navigation. The term is dead reckoning. That is, you don't have the GPS, but still you have to combine your inertial navigation systems with your attitude to do that. Basically, in the simple sense, I'm closing my eyes and then I'm walking. I'm able to know I'm walking, right? How? It's the biological inertial navigation systems in the human body. Where is it? Where is the inertial navigation system of a human body? Any idea? When you turn yourself around very fastly, you will have some giddiness, right? Why is this happening? All are simple concepts. You have a fluid filled in your cochlea, right, in the ears. Right, there is a fluid. You have studied in biology. You have studied in the biology. Okay, there is a fluid filled in it, and you have receptors like sensors. Exactly the same thing. Inertial navigation systems works in the same way. There will be a path for flow of conductive media, say for example mercury. So imagine there is a tube like this, okay, and you have multiple pins. When the mercury is flowing from here to there, it shorts that pin there, contact there. So like that only it is being done. Okay. Have all these ideas into you and then just have your innovation to have more futuristic projects in the future. Any more questions? college students. You can ask me anything. What to do after studies or something like that. I think we have some. Please.
During the rainy season, we are announcing in advance. Tomorrow we are having this area, that area, heavy rain. But unfortunately, fortunately, so what is the, where is the lagging? What is the reason? Now it is short out or
Yes. As you rightly said, the rain doesn't know it is Chennai or Andhra, like that. The clouds just know. We are only demarcating all these things. We have doctor weather records. A place in every campus also has some radar. But in spite of having all these infrastructures and having all these sophisticated instruments, tracking or detecting this weather events in a tropical region or regions close to tropics is really challenging and complicated. As ma'am said, the clouds can pass away. Before a few months ago, we had an incident. There wasn't any trace of any clouds. Like it can project up to 80 kilometers. There wasn't any trace of anything. All of a sudden, there was a huge rain. So definitely our understanding of us needs to increase even better to have better prediction. If you ask me, we are better than 2010, yes. But are we saturated? No, definitely not. We need to have even further observations and validations.
Thank you so much.
So basic answer is sometimes we don't know. Has to be accepted.
Thank you, sir.
But coming to cyclone, we are definitely cautious because cyclone, it's not basically predicted. We are based on the satellite data, our ground truth voice systems gives us yes, it's happening. So the confidence matrix in cyclone is increased much. But if you ask me in other countries like at higher latitudes, like some regions in US and there they can predict rain very well. They can give exact pinpoint information on rain, but they can't predict hurricanes. This is yes, sir, please.
So why are we sending Matsya recently? Already we have the tsunami boy and BTS. So what's the special thing?
Yeah, very nice question. Actually, I don't know. Like there was a mission by James Cameron. After that mission, there was 65 unknown species. Like that species was never known to the world before. Has been taken. And that samples are taken and preserved. So it's basically a person going there, and then it's giving a feel of to see. Will give many insights. Like when you see something the real is, it will definitely give us a different perspective of what is really. And one more thing is curiosity. Like why we need to go to moon? We can only send the spacecraft or something. Seeing physically being there and seeing activity nice. We can feel it. Some of the boys, the bottom measure recorder will continuously measure the data. But this particular thing, actually, if there is any new species found or some other unknown things happening, the human can take a decision and he can maneuver and take that feature for further research. It was really expensive. Thank you. I really enjoyed this session. Thank you.
Thank you so much, sir, for sharing your insights and expertise with us today. Your presentation was truly informative and inspiring. Thank you, sir. A leader is one who knows the way, goes the way, and shows the way. Our faculty coordinator of Xion Little Chance 24, Mrs. Akila Ma'am, stands as a beacon of inspiration. Her exceptional leadership guiding us towards the realization of this remarkable event has been the driving force behind the success of Xion Little Chance 24. It is now with immense appreciation that we invite her to propose the vote of thanks.
Esteemed guest of the day, thank you very much for this wonderful speech what you had given. I thank Dean sir, Dr. Kumar sir for your presence today. Thank you, sir. Ma'am, DP ma'am, Dr. C. Gomati ma'am, today she had just given us the insight about cohorts. It's very good. I take this time for thanking our HOD ma'am, Dr. Shirley Edward, for her constant support for happening this event. We thought of doing only one day. Because of these three persons we have brought all the school students inside today. I thank the management for constant support to us for making this event grand success. I now thank all the HODs of other departments, faculties and staffs. Mainly I would like to thank all the coordinators, faculty coordinators who are standing beside me for making this event. Apart from that, all the college students also who had like second years, third years even helped me a lot with this event to happen. Thank you once again. I would like all the school students to come up for a photograph. We can take it up here. After this, you can go to second floor EC department labs where we had made all the project exhibition to be happening. Thank you. Thank you once again.
I extend my heartfelt gratitude to each and every one of you for gracing us with your presence at the inaugural ceremony of Xion Little Champs 22. As we embark on this exhilarating journey of exploration into the realms of robotics and technology, I hope you all thoroughly enjoy uncovering the captivating and innovative aspects they hold. To all the participants, I extend my sincere best wishes for a fulfilling and successful experience ahead. Thank you once again and let's thrilling adventure.
ஒரு மணி நேரம் ஓடுதுடா ஏட்டு எவனுமே பாக்கலையே அடுத்த வாட்டி எதனா இவனா நம்மளதான் வீடியோ தான் எடுப்போம் வீடியோ மட்டும் பாரு இப்ப தலைவர் தாதி போட்டு ஸ்கிரீன்ஷாட் எடுறாடி நீ ஸ்கிரீன்ஷாட் எடுத்து வர ஸ்கிரீன்ஷாட் எடுறாடி ஏய் Ganesh, Geotech. Clip highlight.